Assalamualaikum and hello everyone. Welcome to a new video of 4.1 Lewis structure. In this video, what we're going to learn is actually determine the formal charge and the most plausible Lewis structure. So on your notes, it will be on page 7. Okay, so here it mentioned that it is often that we can write more than one Lewis structure for a molecule. So if we have more than one possible Lewis structure, so which one is the most stable? Which one is the correct or the accurate representation of a Lewis structure of a molecule? Okay, so to determine the most plausible, to determine the most accurate one, what we're going to do is actually we're going to use formal charge. So here, formal charge is used to find the most stable Lewis structure. And what is formal charge? Is the apparent charges. It means that the charge of our molecule itself ataupun the charge of our atom in the molecule on certain atom in the structure. Okay, so here is actually the calculation to find out your formal charge, where formal charge is number of valence electron minus number of bond minus number of non-bonding electron. Okay, so again, remember here, bonding, number of bond is actually, for example, our fluorine here. We only have one bond. Okay, so if I mentioned, if this is fluorine A, fluorine B. Okay. So, what is actually lone pair? Lone pair is the pair of electron which is not involved in the covalent bond. Okay, if you still remember, this is actually a covalent bond. Covalent bond is actually where the atoms share the electron. Okay, so it means that the fluorine A share one electron, fluorine B share one electron. Okay, so this only one electron per fluorine yang share the electron itself. But the rest of the six electron ni is not used in the covalent bond. So that's why we call it as lone pair. Okay, so here you mentioned for fluorine we have 3 lone pair, because lone pair it means that one lone pair it means that we have 2 electron. Okay, so what happened here is that for our fluorine A and B is the same one. Fluorine, for the case of our fluorine for the case of fluorine, what we have is actually 1 bond and 3 lone pair. Okay, so this is actually a revision of what we have learned for our covalent bond. Okay, so here I'm just going to write down here lah. Okay, but right now, I can calculate the formal charge of my fluorine. Okay, so how do I calculate the formal charge of my fluorine? Fluorine ni, dia punya electronic configuration is actually number of proton is 9. So 1s2, 2s2, 2p5. Okay, so how to calculate the formal charge of our fluorine? So formal charge dia is equal to number of valence electron. Valence is your highest n, which is n equal to 2. So how many electron? We have 7. So here is we have 7 minus number of bond. How many bond kita ada? Number bond dia is actually there's only 1. Okay, but this case around, what it wants is actually minus number of non-bonding electrons. So calculate how many electron is not involved in your covalent bond. Okay, we know that it's memang ada 3 lone pair kan? Sebab 1 lone pair memang kena ada 2 electron itself. But for the formal charge ni, dia nak number of non-bonding electron. So here kita calculate lah. 1, 2, 3, 4, 5, 6. So 7 minus 1 minus lah dengan kita punya non-bonding electron is 6. So formal charge kita is equal to 0. Okay, the same goes here is actually for fluorine A. Fluorine B is the same because it has the same number of valence electron, the same number of bond, and the same number of non-bonding electron. So that is actually only the introduction of what is the formal charge. Okay, so how do we use the formal charge ni to determine the most stable Lewis structure? Okay, so back to the notes here. Okay, here, for example, we have 2 different Lewis structure. What next we have to do was we have calculated the formal charge. Is that we have to determine which one is the most stable ataupun the most plausible the most possible lah Lewis structure. Okay, so first reason that we're going to look at is actually the atoms bear the smallest formal charge. So what does it mean here is that it has the most zero formal charge lah. The most zero formal charge. So at the smallest formal charge, what we're going to take here is actually 0. Okay, so this is it's either this one. Okay, next one. Okay, for example, for the structure itself, when we compare it, we can't when we compare it, it has the same number of 0 formal charges, kan? Okay, next one that we're going to look at is actually the negative formal charge. Negative 2 could be negative 1, negative 2, any negative value lah. Negative formal charge appears on the most electronegative atom. Okay, yang ini, okay, jadi you have to remember, this is actually atom in period 2, SO₄, carbon, nitrogen, oxygen, fluorine. So here is actually, I'm going to do here is actually across period 2, right? Across period 2, what we have is okay, across period 2, what we have here is increasing electronegativity. Okay, so electronegativity is actually the ability of the atom to attract electrons to itself. Okay, so satulah, memang kalau negative charge tu, it means memang dia dah attract electron, kan? Maksud dia gaining electron. Tapi, in this case around, contohnya, when we're going to compare it, make sure the most electronegative atom tu has the negative formal charge. For example, we have satu tu pada carbon, satu tu negative charge pada oxygen. Okay, but we know oxygen ni is the most electronegative, is more electronegative than carbon. So, kalau negative charge tu is actually on oxygen, itu yang kita akan terima. And last but not least, yang ni jarang juga, tapi selalunya yang negative formal charge ni, but here I'm just going to mention, the positive formal charge must appear on the least electronegative atom. So, kalau negative, mesti ada dekat electronegative atom. Yang positif ni appears on the most electropositive atom lah. Ataupun the least electronegative atom. So, another name for it, I'm just going to write down kat tepi ni. The least electronegative ataupun the electropositive atom. Okay. So, that's only the introduction. So, let's do for the calculation. So, calculation A. So, here we have our beryllium chloride. Okay, so on your notes, you don't have this electronic configuration. So, this one is actually I have written down beforehand. So, kalau nak, we're going to take a pause and write it down pun boleh juga. So, again, for any given atom, I write down the electronic configuration first. Because later then you can see what is actually the valence electron. So, if you look here macam beryllium 4, you think it would be 4 ke valence electron? But it's not. The valence electron for beryllium is actually here. 2. Oops. 2. For chlorine is actually 7. Okay. So, now let's do the calculation. So, for example, here, for our beryllium chloride, so we have 2 possible. Okay, this Lewis structure is actually when our beryllium already achieve octet. So, as we can see, beryllium ni, remember that for one bond, mesti ada 2 electron. So, here, our beryllium 1, 2, 3, 4, 5, 6, 7, 8. Chlorine pun, it's already achieved octet. 1, 2, 3, 4, 5, 6, 7, 8. So, that's the first one. Okay, what's the difference? Okay, the difference between structure 1 and structure 2. Structure 2 is that the chlorine itself achieve octet. But then the beryllium only has 4 electrons. 1, 2, 3, 4. But you still remember, beryllium is actually the family for the incomplete octet. Berbal. Beryllium, boron, aluminium. So, the beryllium, it can have incomplete octet. Okay, so dua-dua ni is considered betul lah. But which one is the most plausible? So, let's do it. So, right now, we're gonna do our calculation. Okay. So, for our beryllium, just now I mentioned, beryllium, dia punya valence electron is 2, chlorine is 7. Okay, for the calculation, so first one, I'm going to do the calculation for beryllium. Okay, beryllium, the number of valence electron is 2 minus, okay, minus dengan number of bond. How many bond does it have? 1, 2, 3, 4. Minus 4. Okay, and then minus kan dengan non-bonding electron. Okay, does it have any non-bonding electron? Tak ada kan? Dia memang dah capai octet. So, non-bonding electron, the non-bonding electron dia, It's actually 0. So 2 minus 4 minus 0. So it's actually negative 2. Okay, so that is for beryllium. Okay, so for our chlorine. Chlorine ni, it's actually the same chlorine kan? Tapi I'm just going to label the chlorine A, chlorine B. Okay, lepas tu balik kali ni. Okay, so chlorine, we have A dengan chlorine B. Sama sahajalah. Okay, so again, how to calculate the formal charge? Number of valence electron, which is 7. Okay, 7 minus dengan number of bond. Yeah, number of bond kita. Okay, how many bonds? So, kita kira lah chlorine ni. So, yang ini is the same for chlorine A dengan chlorine B. Ataupun contohnya kalau kamu tak nak tulis macam ni pun tak apa, padam lah. Okay, contohnya Miss buat chlorine A lah, nanti takut confuse tak. Okay, so chlorine A ada berapa bond? 1, 2. Nak number of bond. Ada 2. For chlorine A ni, minus 2. Minuskan dengan non-bonding electron. Number of non-bonding electron. So, what we have here is the non-bonding electron is 1, 2, 3, 4. So, we have 4 non-bonding electron. So, 7 minus 2 minus 4. So, jadi positive 1. Okay, chlorine B pula. Okay, sebenarnya chlorine B ni is the same case sebab chlorine B ni memang ada 2 bond, 2 single bond, and then it has 1, 2, 3, 4. 4 non-bonding electron. So, the same one. So, copy paste sahajalah. Okay. So, sebenarnya, bila kita tengok dekat sini, okay, memanglah nampak. So, you can see here, beryllium ada charge negative 2, chlorine ada positive 1, dia ada positive 1. Tapi, means for the drawing itself, where is the charges? Sebab when we total up the charge here, negative 2 plus positive 2, 0. So, that's why for the drawing of BeCl₂, dia tak ada charge lah. Sebab bila kita tambahkan semua ni, dia memang jadi 0. Okay. So, next kita tengok untuk barium chloride yang incomplete ni. The follow incomplete. Okay. Again, remember for the case of beryllium. Beryllium ni, number of valence kita 2 minuskan dengan number of bond dia. Dalam kes ni, 1, 2. Okay, minus non-bonding electron. Is there any electron ke attached pada dia? Tak ada kan? So, minus 0. So, it equal to 0. Okay, how about chlorine? Ni I'm just going to label A, B lah. Tapi sama sahaja. Chlorine A. Okay. So, yang ini dia... kamu tengok beryllium yang ini lain. Charge dia lain. Ni charge dia lain pula. Okay. So, kita tengok chlorine A pula. Okay, chlorine A is actually number of valence electron is 7 minus number of bond. Okay, chlorine A ni ada berapa bond? Ada only 1. Minus 1 minus non-bonding electron. 1, 2, 3, 4, 5, 6. So, 6. 7 minus 1 minus 6. 0. So, dapat 0. Okay. So, chlorine B is the same case sebab sama sahaja, there only 1 bond and 6 non-bonding electron. Okay. And then the total pun memang equal to 0. Okay. So, sebenarnya kita bukan nak tengok total dia yang mana yang kecil. Kita kena tengok berdasarkan ni lah. Okay. The most plausible Lewis structure is one which the atom bear the smallest formal charge ataupun the most zero formal charge. Okay. So, sekarang ni bila dia tanya determine the most plausible Lewis structure. So, compare lah structure 1 ke structure 2. Okay. For case of structure, sekejap Okay. Okay, for the case of structure 1 ni, the value itself negative 2, positive 1, positive 1. Tapi, for the case of structure 2 ni, all the value is 0. Memang 0 formal charge. Okay, so kat sini, if you still remember the first one, yang memang kita nak, the atom bear the smallest formal charge. Okay. So, apa yang kita nak jawab? Kita kena bagi tahulah. We have to write down the most plausible Lewis structure ni. Okay, yang ni nanti Miss lajukan. The most plausible one is actually our structure 2 sebab dia has the lowest formal charge. Maknanya dia banyak ni kosong lah. Okay, is structure 2. Lepas tu, we have to explain why. Sebab kita bagi tahulah, the structure 2 ni has the smallest formal charge. Dia nak memang the smallest formal charge lah. So which one is the correct one? The most stable one is actually structure 2 ni. Sebab tu lah pun memang beryllium is okay if it does not achieve octet. Dia pun memang ada exception kan, incomplete octet. Okay, so that's the first example. Example B. Determine the most plausible Lewis structure for SO4 2 minus. Okay, so dalam case ni for our sulfur is actually valence electron dia 6. Lepas tu for our oxygen the valence electron is 6 juga. Okay, so let's do the calculation. Okay, so the first one is our sulfur. So okay, sulfur ni, okay, sulfur, okay, how many valence electron tadi? Dia ada 6 minus number of bond. 1, 2, 3, 4, 5, 6. Dia ada 6 bond. Okay, minus, is there any non-bonding electron kepada sulfur ni? Tak ada kan? Sebab semua ni memang attached pada sulfur is all is all the covalent bond. So kat sini kita buatlah jadi 0. 6 minus 6 ni 6, 0. So equal to 0. Okay, so for the case of oxygen, so sekarang ni kita ada 4 oxygen. Tapi for this case round, the oxygen ada yang double bond, ada yang single bond. Mana double bond, mana single bond tu? Ni double bond kita. Ni kita punya single bond. So what I'm gonna do is actually, kita nak buat color apa okay. So sama juga yang ni, yang double bond ni mesti nak buat oxygen A dengan B. Kalau yang ini nak guna oxygen C dengan D. Yang single bond ni nak C dengan D. Okay, so how we gonna do it? So yang ni first one, ni sebutlah oxygen A. Ataupun kalau contohnya kamu tak nak tulis streetnya macam ni kan, sebab ni sama je. Kalau kamu nak buat oxygen A, B tu maksudnya is the same calculation lah. For oxygen A macam ni calculation dia, oxygen B pun macam tu calculation dia. Okay, so oxygen A dengan B. Okay, so the valence electron for oxygen is 6. Okay, minus berapa bond? Okay, oxygen ni dia ada 1, 2 bond. So dia ada 2 bond. Okay, minus non-bonding electron. Remember, non-bonding electron. Okay, so yang elektron yang ada yang tak does not involve in any covalent bond. 1, 2, 3, 4. 6 minus 2 minus 4 equal to 0. Okay. So tu untuk oxygen A dengan oxygen B. Again, kalau nak buat macam ni boleh. Nak buat yang 1 by 1 pun boleh juga. Ataupun nak buat macam ni pun boleh juga. Sama sahaja. Contohnya ni oxygen A. Ni oxygen B. Okay. Okay, so contohnya mana-mana lah. So next is oxygen C. Oxygen C, ni dah buat macam ni, buat je lah sini. Oxygen C, okay, it's different. Kita tak boleh lah kata dia sama. So oxygen C ni dia dah case yang single bond. Lepas tu dia ada lain pula number of non-bonding electron tu. Okay, so for this one, okay, number of valence dia masih lagi 6. Tengok dekat sini lah. Valence electron is still the same based on your electronic configuration. So here it 6. 6 minuskan dengan okay, 1. Guna color ni juga. Minus 1. Okay, why 1? Because here, oxygen ni ada satu saja bond. Only 1. Minuskan dengan 6 electron. Non-bonding electron. 1, 2, 3, 4, 5, 6. So, minus 6. Minus 6 is actually negative 1. Okay. So, oxygen D. Do we have to do a new calculation? We don't have to because it's the same as our oxygen C. So, yang ini pun Miss copy paste sahajalah. Okay. This is oxygen D. Okay, as you can see here, is that for the oxygen itself, for the case of SO4 ni, kenapa dia tu minus? Okay. Sebab bila kita campurkan, we'll add up each of the individual formal charge, memang total dia adalah negative 2. So that's why lah sini, SO4 ni memang ada charge dia 2 minus. Okay, so kita tengok for the case of SO2 tapi structure 2. Okay, sama juga, SO2 ni, S ni, okay, is actually formal charge, number of, okay, bagi nampak sikit number of valence electron dia is 6 minus number of bond. Bond dia ada berapa? 1, 2, 3, 4. Ada 4 bond. Minuskan dengan non-bonding elektron. Non-bonding elektron. Ada tak non-bonding elektron attached pada sulfur? There's none. So here is 0. So here is positive 2. So contohnya kita tengok oksigen ni. Each of the oxygen is the same case. Semuanya single bond saja. Kita tengok number of electron, non-bonding elektron pun sama juga. So ikut kamu lah nak label. Boleh tak nak pun tak apa. You mislabel je lah oksigen A. Okay, so contohnya oksigen A. Again, how to calculate it? Number of valence electron 6 minus number of bond. Bond dia ada 1 sahaja. Minus number of non-bonding electron 1, 2, 3, 4, 5, 6. Minus lah dengan 6. So dapat negative 1. Okay. So here is actually the same lah. Oksigen B, C, D semua sama je. So, kita tengok dekat sini. When we calculate it, total dia, okay, positive 2 minus 4. Sebenarnya sini pun dapat negative 2 juga. Okay. So, next is actually we're going to compare the value of the charge of each the atom itself. Again, kita nak tengok dekat sini. The most plausible Lewis structure is one with the smallest formal charge. Ataupun dalam kata lain dia, the most zero formal charge. Okay, so the most zero, okay, contoh structure tu. Mana ada zero, semua ada value kan? Positive 2, negative 1, negative 1, negative 1, negative 1. Okay, tapi dalam case ni, we have 0, 1, 2, 3. Maknanya 0 ni ada 3 atom yang ada zero formal charge. Yang ini negative 1. So, dalam case ni, the most plausible Lewis structure is actually, ni misal copy paste je. We're gonna use the same reason, tapi this case kita bukan structure tu. Kita nak guna structure number 1. Sebab structure 1 yang has the smallest formal charge. Ataupun yang kata lain dia the most zero formal charge. So that is for example A dengan B. Example C, I believe you could try it yourself.